in this diagram, we are given that the quadrilateral ABCD is a parallelogram. We know the coordinates of A, B, and C, and we will need to find the coordinates of D. So we want to find the coordinates of point D. Maybe the starting point is to let those coordinates be x, y. And then remember that this is a parallelogram. There are several methods of working out the coordinates of D. I'll look at two and just summarize the other two or three. Now the first method will be the method that uses the fact that the diagonals of a parallelogram bisect each other. And so this means we are using the midpoint formula. We need to apply the midpoint formula to use that. So what we are saying is, for this parallelogram here, we can draw the diagonals. So these diagonals meet at that point. Maybe let's call that point O. And so we know that the distance between A and O should be the same as the distance between O and C. Similarly, BO should be equal to OD. You will notice that these two diagonals share the same midpoint. So that point O is the midpoint of the two diagonals. We can use point A and point C to determine the coordinates of O. So let's find O first. So to get O, we need to take the coordinates of A and C and use the midpoint formula to do that. So we get a minus 2 plus 5 divided by 2. That will give us the x coordinates. So I'm adding negative 2 plus 5. And to get the y coordinate, I need to add the 2 to the 1. So that is 2 plus 1 divided by 2. Right, so this will give us the coordinates of O as 3 over 2 and 3 over 2. All right, so we now know that that point is 3 over 2, 3 over 2. And so we can apply that now to the midpoint of BD. Right, so to get the midpoint of BD, according to the midpoint formula, we need to take the x coordinate of B, which is 0, and add it to the x coordinate of D, which is x, and divide that answer by 2. And to get the y coordinate, take the y coordinate of B and add the y coordinate of D, like that. So this will be the expression for the midpoint of BD. But we know already that the midpoint of BD is the same as the midpoint of AC. So you see, you can form an equation here. This midpoint should be the same as 3 over 2, 3 over 2. So if you solve this separately, 0 plus x all over 2 should be equal to 3 over 2, and 0 plus y over 2 should be equal to 3 over 2. I'm just equating the x coordinates to each other and the y coordinates to each other. Right, if you solve this, this should give us x is equal to 3, and that should give us y is equal to 3. Therefore, the point D should be 3, 3. So these should be the coordinates of point D. Now, this is one method of working out the coordinates of that point. Let's look at the second method quickly. In this method, I'm going to use transformation. In particular, I'm going to use a translation. Remember, this is a parallelogram, so this will work for a parallelogram. The best way to look at it is this. If you were to move from point B to point A, I'm translating, so a translation, remember, is just a movement in a straight line. So we can move directly from B to A, but that movement can be analyzed into two movements. The horizontal movement, which means we are going to move horizontally to the left before we can move vertically upward. So that one translation is the same as moving 2 units to the left, followed by 2 units to the right, so that there is 90 degrees. So clearly, to get to A, starting from B, I need to move minus 2 units horizontally and plus 2 units vertically. Now, because this is a parallelogram, we expect the same thing to happen if I were to move from C up to D. So moving from C to D means I should move 2 units to the left as well. So that should be a minus 2 to the left. Then I can move 2 units up. Right, then I will end up at point D. So I'm moving from point C, which is 5, 1, and I'm trying to get to point D, which is given as x, y. And we are saying for us to achieve this, we need to move 2 units to the left, which means we must subtract 2 from the x coordinate, and then move 2 units up, which means we should add 2 to the y coordinate. So in order to get D, we need to take the 5, which is there, and subtract a 2 because we are moving to the left, and then the 1 should be added to 2 because we need to move 2 up. So you will notice that this will give us the same coordinate for D, which is 3 and 3. So these are the two methods that you can use. I think these are faster than the other methods. You can try the other methods. I'll just summarize the other methods here. So the other methods are, if this is a parallelogram, remember in a parallelogram, so this could be your third method. In a parallelogram, the opposite sides are parallel. So opposite sides are parallel. Okay. So how do you use the fact that opposite sides are parallel? You would actually need to work out the gradient of AD. So you can form your equations. The gradient of line AD should be the same as the gradient of line BC. Remember, you are calling this one xy. So when you work out the gradient of AB, you will get an expression in terms of x and y. And then here you can work out the gradient of BC. You will get this one because we know the coordinates of B and the coordinates of C. So these are given. So this will give you an equation in terms of x and y. But the other pair of opposite sides is also parallel. So line AB is parallel to line CD. So you need to form another equation for the gradient of AB equal to the gradient of DC. That's another equation in terms of x and y. Then you can solve these two equations simultaneously and you will get the same answer. So try that and see what happens. This is definitely longer than the first two methods. The fourth method that you can use to do the same thing is to make use of the fact that in a parallelogram, the opposite sides are equal in length. All right. So these are equal in length, which means for that parallelogram there, you would need to use the distance formula to find the length AD and the length BC. These are equal. Now the length AD will be in terms of x and y because our D there is given in terms of x and y. So the length using the distance formula for AD is in terms of x and y. The length of BC can be found, remember we know B and we know C, so this is a numerical value. So this though will give you one equation, and that one equation is in terms of x and y. It is therefore not enough to give you the values of x and y, so we need to take the other sides as well. And so the other sides will be the side AB also should be equal to the side DC. So AB must be equal to DC. That will give you another equation. Once again, DC, the length DC will be in terms of x and y. So this is another equation in terms of x and y. And so you now need to take these two equations and solve them simultaneously. All right. The last method I want to show you is the method of determining the intersection of two lines. Right, so we are given, remember, our parallelogram ABCD. We know that, we know point A, we know point B, we know point C. We are trying to find XY. Right, so XY is that point there. You will notice that that point is where line AD and line DC intersect. So all you can do really is to find the equation of AD, right? Find the equation of line AD. Obviously, you can work it out in the form y equals mx plus c. That equation will be in terms of x and y, and so that is equation number 1. So we know the equation of AD. We now need to find the equation of DC. So do that. Find the equation of DC. Also, you can do that in the form y equals mx plus c. And so that will be your second equation. And all you need to do now is to solve those two equations simultaneously.